Hi, I'm Maddie, a FFAR Fellow and PhD candidate at Washington State University. Oftentimes in the movies, when there's a big problem, a superhero will come to the rescue. And today I want to tell you about a problem we have in wheat and grain production and the unlikely superhero coming to our aid. In this picture, you'll see a typical looking wheat field in Washington. Like much of the wheat and grain production in the state, this field is unirrigated and located in a dry region. As you can imagine, low moisture availability is a key issue for farmers in these cropping systems. Adding organic matter to the soil can help with this challenge, as it can increase the soil's ability to store moisture and improve other aspects of soil health. Now I want to tell you about the superhero resource helping farmers in these systems add organic matter to their soils while also supplying nutrients to their crops. Like a superhero, it started out as one thing, but after a transformative process, it became something quite incredible. I'm talking about our poop. Yes, that's right, our poop is the hero of this story. Or should I say biosolids, which is the name our poop goes by when it dons its mask and cape, or in other words, goes through the wastewater treatment process. This superhero's origin story begins when we flush the toilet. During the wastewater treatment process, solids are separated from liquids, and bacteria are used to digest those solids. Much like the radioactive spider that bit Spider-Man, this process transforms our poop into something more than it was before. Biosolids can be used as alternatives to other fertilizers because they contain plant essential nutrients from the food we eat. These nutrients would otherwise be lost through landfilling or incineration, but with land application, they're returned to agricultural systems. Biosolids also contain around 60 to 80% organic matter, which, as you learned earlier, is a bit of a soil health superhero in its own right. This is where my research comes in. I'm a soil scientist, and my work focuses on exploring how biosolids impact soil health and sustainable crop productivity in these dry systems. We're particularly interested in how biosolids affect available water holding capacity, which is a measure of how much plant available water a soil can hold. In our research, we've found that long-term biosolids applications increased available water holding capacity compared to a synthetic nitrogen fertilizer. This is exciting as it suggests that on top of providing adequate nutrients, biosolids are also improving the soil's ability to store water, which can impact the farmer's bottom line. Looking back at this field, it may appear to be just another Washington wheat field. However, there is more to it than meets the eye. With the superpowers of biosolids, nutrients from the food we eat are being recycled back into agricultural systems as alternatives to synthetic fertilizers. And the organic matter added with biosolids is helping to improve water holding capacity in these dry cropping systems.